Yeah, Ryan, do you have it? Right, let me stand up. Jonathan, Bruce, you don't have it?
I'm not responsible. Can't even keep up with a sheet of paper.
Okay.
That makes
So
me.
you all have everything that you need to have. There's your homework.
Yep.
Again, until we get caught back up, A4 will have a different homework assignment than B2, B4, until we're all kind of leveled out, okay? So that should take care of everybody at this point. Are we all good? Okay. What's the number on the bottom? Megan? Do you need to do it?
Mikey.
Gentlemen, that's it. I have it okay. Goodbye. Let's get him home. All right, and then the rest of you, hang tight. All right, let me go down roll call, please. Pausing. Elliot. Chloe. Here. Marissa. Here. Hoffman. Here. Isabel. You ready? Down the hall for me to call roll. Okay. I'm done. Keith. Loomis. Grayson. Moore. Morgan. Osby. Pope. Russell. Schroeder. Snavely. Mary. Megan. Fetter. Seagard. Swillinger. Throckmorton. Walsh. Wadley. Green. Here. Okay. So the next thing coming back is our new unit. So we're starting today. 9-2. You're breaking my stuff? Put the ruler away and don't touch it. Your tax, I'm not laughing. Your tax dollars, this school did not buy that. That is out of my pocket, my personal checking account. And y'all are destroying it. And if you didn't break it, you're making it worse. You can roll your eyes all you want. I'm not happy. Your focus is poking rulers through my stuff. Thank you for ruining it. I appreciate that. I'm going to tell you something else for anyone in here. You don't want to get called out in my classroom, don't act like school in my room. I can't speak to you if you're not misbehaving. Alright, so what's coming back is the beginning of chapter 9. My goal, and your goal, is to get 9-1 and 9-2 done, mastered, everything before we go out here on Friday, okay? So if you're not going to be on Friday, you need to make sure that you're getting the material. This is algebra. Yes. 2. So you guys are gonna be a little bit different, because I'm not giving you homework on this material like they got, because you have enough with your 8. Is everybody okay with that?
Yeah.
So we're not gonna do homework on this, but that means Wednesday you might have extra homework, and then we'll be back with our regular class. All right, so the first thing we're gonna work on is GCF and factoring polynomials. Okay, this is 9-1. What do we call a whole number that's greater than 1 and only has a factor of 1 in itself? What do we call those kind of numbers? Prime numbers. Okay? So a prime number is a number that only has 2 factors, 1 and itself. Another number we give a name is a number that's greater than 1. It's a whole number, but it has 2 factors, or more than 2 factors. It can have infinite factors. What do we call those kind of numbers? It does constant. No, not consecutive. Nope, constant is a number. One constant, but they are constant. It's not.
I remember I learned it all the way up to like composite.
Composite. So going back to elementary math, prime number is a number that only has 1 factor, itself and 1, and a composite has more than 2 factors. And why are you talking again, just to annoy me some more? Not the smartest move right now, is it? No. Prime factorization. Now, some of you learn, depending on your teacher, your prime factorization differently. Again, I can't speak to you, Mr. Schroeder, if you're not acting like a fool in my room. Okay. Next. Your innocent friend don't work, because I got your mom on 1-800 speed dial. Okay. All right, talk to Dan, we can call mom next. Prime factorization. Okay, prime factorization, again, depending on how you did in elementary and 6th grade, I might do a little differently. It doesn't make it wrong, it's just different. So, prime factorization is basically when you take a number and you write it as a repeated factor and all those factors are prime. That's prime factorization. So to do that, we start with the number that we're given, 90. And this is called a tree diagram, if you've ever seen it. And we're going to start with the basic first prime number. What's the first prime number you get to? 45. Not 3.
2.
Good, RJ. It's 2. 1, for some reason, math world wants to argue if it's prime or composite. I don't go there. So 2 is the first prime number we get. Does 2 go into 90? 45 times. If you start with your least prime number and work your way up, it keeps your numbers in order and it keeps it organized, which is what we need to do the bottom. So, does 2 go to 45? No. What's the next prime number? 3. Does 3 go to 45? Okay. And you notice that what we're basically doing is writing the factors underneath, and the factors are 45 and 15. We always ask ourselves, is this last branch over here prime or composite? This is composite. So, does 3 go to 15?
Yes.
How many times? Is 5 prime or composite? So when the last 2 branches end up being prime, you are finished. And basically, we take all the prime numbers that we found, and that is then written as a product. 2 times 3 times 3 times 5, and that is your answer. Now, this is not where we're going. This is a process to find what we need for our next section. Okay? What's wrong, Schroeder?
I said if you multiply together, it equals 90.
There we go. That's what No, that means we're checking the work. Good job. That's what we wanted to do. All right, so over here we have negative 140. Now back in chapter 1, we talked about negative numbers, and there's one factor you always pull out, and that's what really made that difference between parentheses and no parentheses. What do I need to pull out of a negative number? A negative 1. Okay, that's the first thing each and every time we want to pull out is the negative 1. Then we're just going to factor what's left. Is 2 going to 140? How many times? 2 going to 70? 35 times. 2 going to 35? 3?
No.
No.
That's 5.
What's the next prime? 5. Does 5 go in? Is 7 prime or composite? Prime. So you're done. We're going to underline all those primes, and then that multiplied together. I'm listening for it. Just keep talking.
What
do we call it?
I'm lost. Yeah.
I remember I did it like a timeline.
Huh?
I did it like a timeline.
Of course, this number on the right-hand side is the one we're always looking at. As long as it's composite, we have to keep going. That's why we always write the primes first. When there's primes at the end, we're done. Okay? So, now we're going to move to the algebra world. We're not done yet. We're just learning how to write these. Would you stop?
That was me.
A monomial in factored form, when it is expressed as the product of prime numbers and variables, and no variable has an exponent greater than 1. No variable has an exponent greater than 1. So this is pretty simple. The first thing we would do is take 12 and write it as prime factorization. So this 2 going to 12, 6 times. 2 going to 6, 3 times. So we finish because 3 is prime, and we write 12 as 2 times 2 times 3. Now, will I put 8 cubes up there? No, because the rule says that it cannot have a power greater than 1. So how would I write 8 cubes, Dylan? I cannot write 8 cubes because the rule says it cannot be greater than 1. How do you think I'm going to write 8 cubes in prime factorization form? Jonathan? A times A, B times B times B times C.
And I wish math was like that.
You're not going to want to make that kind of all right, that's the answer in what they call factored form. We're going to use the factored form to find GCS. If you flip it over, we're going to find GCS of all this good stuff. Okay, to find the GCS, we need to work with the factored form. Now, some of you will need to do the factored form until you get really good at it, and then you'll start dropping that process. The process helps you see what we're doing. So let's start again with negative 66. What's the first thing we factor out, Emily? Chris, is 2 going to 66? How many times? Excellent. 2 going to 33 post?
Yeah.
How many times?
Oh, no, it doesn't.
Okay, the 3 from 33. How many times? 11. Do I need to keep going? Nope, because 11 is prime. And so we get negative 1 times 2 times 3 times 11 times B times A times A. And there's your factor form. Yep, yes, sir. Oh, the A times A times T? Round order? The numbers usually go from least to greatest, because we start with that way on our tree. The variables can pretty much stay in the order in which the columns go, in case they don't do it. The product of the common prime factors is called the greatest common factor, and that acronym? ECF. The key word here that we're going to work with is common. They both have to share it. They have it in common. Right? So we're going to start with a very basic elementary GCF. How does it work? And then we're going to apply that same process to our monomial. Okay? So we're going to start with 12. And we already saw it here that the prime factorization for 12 is 2 times 2 times 3. Is everybody okay with that? I just pulled that from up here. We already did. 16, 2 times 2 times 2 times 2 is 16. I'll get out the Jesus. Everybody okay with that? So the key word was what? What they have in common. So I'm going to take color pencils, and I'm going to circle pairs they have in common. So they have a 2 in common. They have another 2 in common. Do they have anything else in common? So basically the GCF are these two numbers multiplied with 2 times 2. So the GCF of 12 and 16 is 4. Again, a lot of you should be able to do these in your head, but as we move to the monomial, it does get a little bit trickier. Wait, whoa, calm out. Corey.
Is it okay just to do it in your head?
No, not yet. Kristen. It's what number they have in common. Both of them have a 2. Huh? You would have to know. You would have to almost do like a factor tree or factor table. I mean, whatever method you found factor to is great. Doesn't matter to me. Yeah, because I know that 4 and 16 is the highest number that goes in the both of them. Like if I think about factors of 12, 1, 3, 4, and 12. 1, 2, 3, 4, 6, and 12. The highest number that goes into 16 and 12 that they have in common is 4. Yes. Yeah, I'm okay with that after we get to the second part. Okay. So the next one is 38 and 54 as these monomials. So the first thing we're going to do is come up here and write 38x squared y in its factor form and 54 xy squared z in its factor form. Alright, so find the prime factorization for 38 and then stop. Find the prime factorization for 38 and then stop. Elias, what are the prime factors for 38?
I'm not done yet.
38, Tuesday? Is 19 prime or composite? You're done. 2 times 19 times X times X times Y. Nothing. Prime. 54, go. Find the prime factor equation. Do not do the variables, just 54. We want to check before we move on. Logan, what are the prime factors for 54? Excellent. So it's 2, 3, 3, and then X, Y, Y, Z. So to find the GCF is the same process as if you're just doing numbers. So the first thing I'm going to do is take my color pencil and I'm going to identify the first thing they have in common, and that's a 2. This has a 3, this does not. This has a 19, this does not, so you're pretty much done with the coefficients. What else do they have in common? Variables. They have the X in common. And they have a Y in common. Once you found everything they have in common, you just multiply that. 2 times X times Y is 2XY. Okay?
So when they had 2x in common, one had y squared.
All right, everybody good? What? All right, do number 3 on your own.
You should just do number 3.
Just number 3. Yep.
When you're like, finding, once you do the factorization part, and you see what they have in common, do they have to, like above each other, or can it be like anywhere?
I'm sorry, say that again?
Like, do they have to be like right on top of each
No.
other?
No, they don't have to be right on top of each other. If you want to, like, if they're not, maybe shade them the same color so you know you can use them.
Okay.
Yeah. All right, number 3, pausing. Excellent. All right. Yeah. We'll find out.
Oh. You will.
Mary, are we doing number 4 right now?
All right, so let's do number 4.
That extra question here?
18
I know.
That's y, and 36 y squared is 2 times 3, oops, times 2 times 3 times 3 times y times y. So one of the things Kristen was asking was, what if they don't like get right under each other? That's okay. So basically, we know they have the 2 in common. And we can see that these 2 don't line up. So I just kind of squiggly around them to get them there. So there's my 3. Then I have another set of 3s. And then I have a y. So even though they don't line up on top of each other, that's okay to kind of squiggly around, just grabbing them or highlighting them. Yes, sir.
Like, for number 1 and 3, can't you just subtract that?
Kyle, why?
No, sir. Okay? So the answer to GCF is just multiplying all that together that we just found. 2 times 3 times 3 is? And? Good. Everybody okay with that? Alright, so here is your task for the remainder of the class. The very top. Up top. The top you're finding the GCF of both these. Okay? 2 times 3 times 3. 2 times 3 times 3. Okay, you got it? Alright. So the top is the GCF. Now, you can notice that these are increasing difficulty because now you've got to compare what? 3 monomials. When you're comparing 3 monomials, that means all 3 have to have the same thing for that to be a common factor. Does everybody hear that? Can't be in 2 and not the other one. It has to be in all 3 to be common. Now, down bottom is a blast from the past.
Oh, really? That's easy.
Okay? These are dividing. So remember, you do this one, and then you come back and you do this one. So it's really 18 divided by 4 plus 12 over 4. That's what this whole thing down bottom is. That's at 12 halves divided a polynomial by a monomial. All right, get busy. Go. You're talking.
Oh, I'm gonna go check her recycle.
Yes, sir. Any questions, RJ?
So if we, I just like to, one, just do like -1.
Say it again.
So if it was like,
What are you looking at? H, there is no common factor between 1 and -2.
so,
Would not be -1. I mean, your factors would be -1 and 2, but there still has no factor in common between 1, I mean between 2 and 11. There's nothing in common. Nope. Do the whole thing, you'll see. All right, get busy. Yes, they do.
Plus or minus stuff.
Yes, but remember, that's like the -2 is going to be -1 times 2, so they're still considered as a factor. You want to check out the -1 if they have it in common. Yeah. Now you're just working with them as,
She has
You might
something.
need it.
Miss Tuck, when you run out of paper again, let me know. I'll bring it back. I'm gonna need 3. About 20 sheets.
Do we have to put GPS equals if we use like 5 feet?
What happens if you don't get rid of like the negative variable? What happens if like for negative 15x, what happens if you don't get rid of the negative variable?
It's okay.
Like it'll still work out to be
It's
the
just
same.
not, for it to have a negative GPM, both of them have to have a negative one.
Yeah.
So if they don't have a negative one in common, it doesn't work. All right, passing back these quizzes. Some
Yes.
are very, very good. This is the graphing still.
I know, but I still probably got
Okay.
quizzes.
Really nice grades. Some of you do need to come in and get some extra help, okay? Especially before the test happens. Pausing.
100.
And how would you know that?
Because I walked up there earlier. Because I walked up there earlier and saw it.
Huffman. Code to take home. Oh, well, you went the one that we just saw. I'm working on those now. I'm starting next 2 minutes.
So that was just a coincidence on the front, right?
What do you mean?
Track every time. Well, 3 out of 4, 3 out of 4 like that.
See, that's just it with math, and that's the thing, not just with some of them. So if that
You
happens.
can't work like half the
Yeah, it
time.
has to work all the time. Brayson. All right, you all are working. Swillinger. Morgan. Marissa.
this is the one we did at home, that's why. Yeah, the other one I can get on. This one. Yeah, I did this on the bus ride. So, couldn't expect much.
Wadley,
Couldn't expect much more. Want to see somebody else do it. I'm still want to see what happens.
Kyle,
Schroeder. Yeah. Come on, big ass. Ah, there you go. Yeah, do that on who's right. Hey, what'd you get? I'm sticking the 80s. You get that.
Kristen. If you need me, come up and ask, okay? Henry. Igor. Mary. Loomis.
I was gonna go to Algebra. Let me see if I can find it. Take that on. Wait till the next quiz comes back. That I got. That'll be a nice. Hold that when you get like a 40. You finish the one. She's doing that. I don't think it was that hard. I'm doing these wrong because you look over. That's how I feel. Thank you. Oh.
There isn't any talking.
That was nice. Doing it wrong.
Yeah. You don't know things.
Now just figure it out.
Stop
it. Stop. Stop.
I like that laugh.
You get some
Oh, I got more papers up here for you.
Oh, yeah. Can I have my quiz?
Yeah, we're working with two. Taylor, Melissa,
Nhưng mà nghe từ mỗi cái hai bài cấp gì không? Nghe tay mà nó mà. What? No, I don't know. And a baseball shirt.
Lauren,
I usually go to that see, that's like really. What? The eyes go they're like all red.
yeah.
Hot.
All right, Mark, Rain, Corey,
Yes.
Dylan, Nick, Jonathan,
Late. Oh. It'll get that one, yeah, I gotta send it.
Marissa, Chloe, Bradley, Kristen, Leslie, Doris, Guys, Cecile, Kristen. Hey, it is silent coming out. Just sit down unless I call your name. Kelsey, Logan, Megan. Sit down.
You have a nice string there.
Keys, Carter, Fozzie, Mary. Dude,